Hello students, this is the video on topic tests that we at Bodhee Prep have prepared for you. These topic tests are to be attempted once you've covered the basic concepts of a topic. The test will help you understand whether you're able to apply those learned concepts in a test or not. Once you give the test, that is when you look at this video. This video tends to give you or tries to give you a perspective of what could have been a good attempt, the amount of time that you could have spent on questions, and the overall solution also for the questions. If you like the test, there are more than 200 topic tests available on the Bodhee Prep Android app. The link for the app is in the description below. Do download the app and make use of these tests. This specific video is about the topic HCF LCM, and the test number is 4 for this topic. If you look at the overall analysis, I think it was a difficult test, and even 5 questions or five to six questions net correct would ensure that you get a 95 percentile plus in a equivalent examination. Ideal time to attend this attempt this test, that is going from question 1 to 10, would be about 20 to 23 minutes, because the difficult questions will take time. The easy questions were the ones which could have been done pretty easily actually. If we look at the questions, question number 1 says 3 cakes of weight 780 grams, 840 grams, 960 grams are cut into small pieces, all of which are equal weight. So each piece has to be such that it divides these three numbers. Each small piece must be as heavy as possible. So the size of each piece will be the HCF of these three numbers, so that it divides all the three and is as high as possible. If one piece is shared by exactly 2 children, then how many children can the pieces of cake be given? If we look at the HCF of these three numbers, we take the difference between 780 and 840, which is 16. The difference here is 120. The HCF of 60 and 120 is 60. So the HCF of these three numbers becomes 60. So the size of the small piece will be 60 grams. And therefore, number of pieces in which the first cake can be divided is 13. Number of pieces in which the second cake can be divided is its weight is 840. And 14 60-gram pieces are being cut. So 14 pieces. For the third one, 16 pieces. So total number of pieces that we have is 14 plus 16, 30 plus 13, which is 43. Each piece goes to 2 children, and therefore total number of children who can eat these cakes or can get these cakes are 43 pieces, each piece to 2 children. So 86 children can be given the cake pieces. Option A becomes the answer. Again, a direct application of HCF, we would have done similar questions earlier. So I'm saying, because at least this was a catch here, exactly 2 children, which could lead to an error if we miss the detail. Therefore, I am saying moderate, but in any case, not more than 2 minutes to solve this question. What is the number of ordered positive integer pairs n with m plus n is 500? M plus n is equal to 500, such that m and n have to be co-prime. HCF of m and n is 1. Now, if we just simply put examples, if m is 1, n can be 499, which is okay. If m is 2, n will be 488. As we can see, 2 and 488 are not co-prime, 2 is common. Similarly, if we put 3, 497 will be fine. If 498, not 88. 4 plus 496 will be a problem, because again, both have 2 as factors. 5 and 495 will also be problem, because both have 5 as a common factor. So basically, since 500 has 2 and 5s as its prime factors, if one of the numbers is a multiple of 2 or 5, the other number by default has to be a multiple of 2 or 5, so that the equation remains, because the right hand side is a multiple of 2 and 5, 2 or 5. Again, if this happens, m and n will not be co-prime, and therefore they will have an HCF more than 1. So basically, m can take all values from 1 to 500, which are not multiples of 2 or 5, or both. So basically, we are looking for co-prime numbers less than 5. Co-prime numbers less than 500. Numbers which are less than 500 and co-prime with it. So for this, we can directly use the Euler formula. We say 500 into 1 minus 1 by 2 into 1 minus 1 by 5, which is 500 into 1 by 2 into 4 by 5, which comes out to 200. So m can take 200 values. Correspondingly, n will have a value, and therefore 200 sets of m and n are possible. If we do not know this formula, we can also count multiples of 2 till 500 will be 250. Multiples of 2. Multiples of 5 will be 500 upon 5, which is 100. Common multiples will be multiples of 10. Multiples of 10. Multiples of 10 will be 500 upon 10, which is 50. So total multiples of 2 or 5 will be 250 plus 100. These 50 have been counted in both cases, so minus 50, which gives us 300. So out of from 1 to 500, there are 300 numbers which are multiples of 2 or 5, and therefore 500 minus 300. 200 numbers, and value we're getting here are numbers which will not be multiples of 2 and 5, and therefore m can take that value. N has a corresponding value. Again, the question is not very difficult per se. I'd say moderate, and if we know this concept, technically we are just expected to put this formula in. 1.5 to 2 minutes should be the right time to solve this question. What is the product of GCD or HCF of 84 126, LCM of 84 126? So basically we have to find out GCD into LCM. Now for two numbers, we know that the product of HCF and LCM is simply the product of two numbers of the numbers, and therefore the required product is nothing but 84 into 126. Can't think of any. What? I'll just simply multiply. 6 1 24, carry forward 2, 4 to the 8 10 0 1, 504. 8 will be double of this. So 1008. 10584. And that becomes my answer. So I think one of the easier questions, direct application of the formula, and even multiplying is not very difficult. Easy question, not more than 60 seconds to solve this question. Suppose G is the greatest common divisor of 5913 and 7592. C is the greatest divisor of 481 851. So G is the HCF of 5913 and 7592. We can look at the difference or try to factorize. C is the HCF of 481 and 851. Taking the difference may not be a bad idea. And D is the greatest common divisor of 1827 and 3248. Compute G plus C plus D. So direct calculating HCF is what we have to do. For 5913 and 7592, if we start, 5913 is divisible by 3. 3 19s are 57, 71971. Again divisible by 3. 3 6 are 18, 17, 657. Again divisible by 3. 219. Again divisible by 3. 73. If I divide 759, now 7592 is not divisible by 3. So if we divide 7592 by 73 directly, 73 ones are 73. 2, 9, 0, 2. So 4, 292. So basically 5913 is 3 raised to power 4. 81 into 73. 7592 is 104 into 73. Therefore, value of G comes out to 73. When we look at C, 481, 851, I'm looking at the difference. 0, 7, 3, 370. 370 does not divide either of the number, divided by 5. So if we try to factorize this becomes 5 into 7, 5 is 35. 74. Again, does not. 5 into 2 into 37. The only possibility for C is 37. It should divide the numbers. I'm just checking with, say, 481. 37, 1s are 37, minus 11, 111, 3s are 111. So this is done. C becomes 37. Now we look at D. D is 1827, 8 plus 1, 9, 9, 611. So let's start dividing 1827 by 3. So 609, 3, 203. 203. Does this divide? 203, I'll check with 3248. 203, 3248. Ones are 203, 1218. 6 are. So this is 203 into 9. This is 203 into 16. So D becomes common factor 203. G plus C plus D will be 100, 110. 110 plus 203 will be 313. So that this becomes my answer. Again, I'll call it a easy question because the concept is pretty simple. We just have to find out the HCFs. Ideally, if you're doing it properly, you should be able to do it in about 2.5 minutes. Even if suppose you come across a question like this in an exam where the time pressure is not very high, you can always attempt this question because you'll surely get the answer. When 5911787,937 and 131167 divided by x, they leave the same remainder. So when they leave the same remainder, all we need to do is take numbers two at a time, look at the difference and find the HCF of that difference. Standard procedure, find the sum of the digits of the largest possible value of x. 87937 minus 59117, 820, 1728, 131167, 87937, 32, 9, 10, 11, 178, 9, 10, 11, 189, 43230. Now this is 14410 into 2. This is divided by 3. 3 ones are 3. 4410 into 3. So the HCF of these two numbers is 14410. And therefore, if we divide each of the number by 14410, we'll get the same remainder. This is the largest value, sum of digits being 1 plus 4 plus 4 plus 1, which is 8 plus 2, 10 becomes the answer. Again, it is the standard format of the question, and therefore I'm saying an easy question, 90 seconds, good enough to get this answer. Find the number of ordered pairs AB such that the least common multiple of A and B is 70. LCM of AB is 720, not 70. 720 can be factorized as 8 into 9 into 10, which is 2 cube into 3 square into 2 into 5. So the LCM has to be 2 raised to power 4 into 3 square into 5. Now, in this case, what we do is if we look at powers of 2, the cases possible are powers of 2. A could have power of 2 as 2 raised to power 3, in which case B could be 2 raised to power 4. In which case B could be 2 raised to power 0, 1, 2, 3 or 4. If B is 2 raised to power 4, in that case A could be 2 raised to power 0, 1, 2 or 3. I am not putting A as 2 raised to power 4 because that case already has been counted. So number of cases will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Since the power of 2 is 4, the number of cases for 2 comes to 2 into 4 plus 1. Similarly, for 3, it will be 2 into 2 plus 1. 3 raised to power 0, 3 raised to power 1, 3 raised to power 2 can be clubbed with 3 raised to power 2, 3 raised to power 2, 3 raised to power 2. This is A, this is B. Or we can have 3 raised to power 2 here, 3 raised to power 1, 3 raised to power 2, 3 raised to power 0. So 1, 2, 3, 4, 5, which is 2 into 2 plus 1. And for 5, because the power is 1, we will have 2 into 1 plus 1. So number of cases possible for power of 2 is 9. For power of 3 is 5. For power of 5 is 3. So total number of possibilities will be 9 into 5 into 3, which comes out to 135 becomes the answer. some concept of factors counting is also there, and therefore I'm saying moderate level. But if we know the concept, 2 minutes is good enough to answer this question. How many positive integers n are there such that n is a multiple of 5? N is a multiple of 5. LCM of 5 factorial and n. Now 5 factorial is 1 into 2 into 3 into 4 into 5, which is 2 square. 2 cube into 3 into 5. So LCM of 2 cube into 3 into 5 comma n is equals is equal to 5 times of greatest common divisor, GCD or HCF we can write, is 5 times of HCF of 10 factorial. 10 factorial will be 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10, which will be 2 square 3, 2 raised to power 4, 2 raised to power 7, 2 raised to power 8, for 3, 1, 2, 3, 4, 3 raised to power 4, for 5, 1 and 2. This is 10 factorial. So 2 raised to power 8 into 3 raised to power 4 into 5 raised to power 2. Highest common factor or greatest common divisor of 10 factorial and n. This is the equation that we get. Clearly, n has to be a number which comprises of 2, 3 or 5 only. Because if n has 7, it will not be counted here, but LCM will have 7. So the left hand side will not be 5 times of the right hand side because we'll have a 7 on the left hand side. On the right hand side, there will be no 7. Now, what can be the power of 2 for n? If the power of 2 for n is say less than 3, the LCM will have power of 2 as 3 and the HCF will have power of 2 as the power of n. So if power of 2 here is say 2, the LCM will have the higher power, the HCF will have the lower power, and therefore 2 raised to power 3 will not be equal to 5 times 2 raised to power 2. So the power of 2 can be anything starting from 3 up till 8. 3, 4, 5, 6, 7, 8. So number of cases possible is 3, 4, 5, 6 cases are possible. The logic here is if the power of 2 in n is 2 raised to power 4, in LCM case we will pick the higher power which will be n. In case of HCF will pick the lower power which will be n. So in both cases the power of 2 in n will get picked up if it is between 3 and 8. Similarly, when we look at power of 3, it could be anything from 3 raised to power 1, 3 raised to power 2, 3 raised to power 3, 3 raised to power 4 by a similar logic. I missed the 7 here as well, sorry. So n has to be 1 of 2, 3, 5, 7. I completely missed this. Now if you look at the power of 7 first, because we have a 5 here, so we'll deal with it later. If you look at the power of 7, n can have a power of 7 and nothing beyond 2, 3, 5, 7. The power of 7 here, if the power of 7 is 0, LCM will not have the power of 7. In HCF also, we will take 7 of power as 0. If the power of 7 is 1, in the LCM it will be taken, in the HCF also it will be taken. If the power of 7 is anything more than that, then it will be taken in the LCM but not in the HCF. So power of 7 could be 0 or 1. Like 2 and 3, similar logic. Two possibilities. Now what can be the power of 5 in n? We know that n is a multiple of 5 given in the question. Suppose we take the power of 5 as 1 in n. In that case, the LCM will have power of 5 as 1. In the HCF, we will have the power of 5 as 1 here. This will get multiplied by 5. So 5 will not be equal to 5 into 5. So 5 cannot have a power of 1. If we have n as 5 square, in that case, LCM will take 5 square. HCF will also take 5 square. But 5 square will not be equal to 5 into 5 square. If we have power of 5 as cube, In the LCM side, we'll get the higher power, which is 5 cube. This 5 is already there. In the HCF, we'll take the lower power, which is square. This is the only case when the power of 5 can be equal. So the only possibility is we take 5 cube, because if we take 5 raised to power 4 on the left hand side, or the power of n, then we'll get 5 raised to power 4 on the left hand side. This 5 is already there. On the right hand side, we'll take the lower power of 5, which is 5 square. So they will not be equal. So the only possibility for 5 is that it has to have 5 cube. So this value of n, number of cases possible is 6 into 4 into 1 into 2, which becomes 48. So this uses some questions that the concepts of LCM that we had used previously, the concept of factor, and then combines all of them. This I'll say as a difficult question. Even if you know what to do, it will take you at least 2.5 to 3 minutes to solve it. Cracking such a question in the exam might actually be difficult. Let A, B, C, and D be positive integers such that HCF of A and B is 24. HCF or GCD of B and C is 36. So A and B have to be numbers which are multiples of say 24x and 24y. If from here we can say B has to be 36, A 36z, and C has to be 36, say W. If we combine this, we can say B will be nothing but 12 into 2, and here it is 12 into 3. So B has to be of the form which is 12 into 2 into 3 into something. Suppose I am combining this and I am writing 12 into 2 into 3 into P, where P cannot be 2 or 3. Again, if you look at C further, HCF of C and D is 54. 54, 54, say U and V. If we combine these, we can say this is 18 into 2, 36. 18 into 3, 54. So C has to be 18 into 2 into 3 into say Q. The GCD of DNA lies between 70 and 100. Each of the following must be a divisor of A. Now, if we look at A, 24 and 74. A is 6 into 4 into X. D is 6 into 9 into U. This is U, this is V, sorry. So 6 into 9 into V. We have to find out their common factors. 6 obviously will be common. Now something has to be common between X and V, and it should be such that it is not amongst 2, 3 and so on. Now if we put the common factor to be 5 between X and V, the GCD will not lie between 70 and 100. If we take it to be 7, again it will not lie between 70 and 100. If we take it to be 11, it will not lie between 17 and 70 and 100. But if X is a number of the form which is a multiple of 13, and V is also a multiple of 13, that 13 will have nothing in common with 24y. Similarly, that will have nothing in common with 36 and 54, and therefore we can say from the options, if we have X and V as multiples of 13, we can have the HCF of A and D as 78. And therefore, from the options, we can say A has to be divisible by 13 to get an HCF for A and D in this range. And therefore, my answer becomes option C, 13. Again, this question answer is moderate to difficult level for sure. 2.5 minutes to solve this question once you figure out what is to be done. Find the number of ordered pairs Mn such that Mn are positive integers in the set that is given, and the greatest common divisor of 2m plus 1 and 2n minus 1 is not 1. Now suppose if I write m as 5x and n as say 5y. So 2 raised to power m can be written as 2 raised to power 5 x plus 1. 2 raised to power n becomes 2 raised to power 5 n minus 1. This becomes 32 upon x plus 1. 32, this is y minus 1. Now we want that there has to be a common factor amongst these two numbers, say p, and this should not be equal to 1. Now, can we say here that if we divide 32 raised to power x plus 1 by p and we need a remainder 0 divisibility, that means 32 raised to power x by p should have a remainder of minus 1. And from here, 32 raised to power y minus 1 is also divisible by p. So 32 raised to power y upon p should have a remainder of plus 1. So that this gets cancelled out. Plus 1 minus 1, minus 1 plus 1. And therefore we can say that also these two numbers are of the same format. And therefore from here we can say that x and y have to be such that x is odd, y is even. Now x is odd, y is even, and we can have multiples here. So we can say that the basically the deciding factor will be the power of 2 here, and that is all that is needed. So if we look at m could take values which are odd, say 0, 1, 3, 5, 7, 9 up to 29. In the set of 1 to 30, that will be 15 values. These can be combined with values of n, which are powers of 2. 2, 4, 6, 8, 10, and so on up till 30. And therefore, from here, we'll get 15 into 15, which is 25, but 225 sets. But this is not the only case. There could be a possibility where m could take powers of 2 or single powers of 2, which is 2, 4, 6, 8, 10. 2, 4, 10, 2, 6, 10. 10. 2 1s are 2, 2 3s are 6, 2 4s are 8, 2 5s are 10, 2 6s are 12, 2 7s are 14, 2 8s are 16, 2 10s are 20, 2 10s a multiple of 4. 18, 20 goes away, 22. We just leave a gap of 1. 22, 24 goes away, 26, 28 goes away, 30. 1, 2, 3, 4, 5, 6, 7, 8. M could take these values. Now, what I'm trying to say here is if M is 2 raised, if M is 2, so I'm writing 2 raised to power 2 plus 1. What we can do is, we can take the square inside and say 4 raised to power 1 plus 1. So here, the power becomes odd. The only thing is correspondingly, n has to have a power of which is a multiple of 2. And therefore, the value of n will be 2 times of this. Or, if not 2 times, 4 raised to power 4, 4 raised to power 6, anything will do. So n has to have a power which is at least 1 higher than the power of 2 which m has. Since m has a power of 2 as 1, so n could be 4, 8, 4, 8, 12, 16, 20, 24, 28. So 1, 2, 3, 4, 5, 6, 7. 8 possibilities for m. 1, 2, 3, 4, 5, 6, 7, 8. Correspondingly, 7 possibilities for n. So 56 extra possibilities. Similarly, we can say m could be a power multiple of 4. So in that case, we will say 2 raised to power, for example, m is a multiple of 4, which is say 12. We can write this as 2 raised to power 3 raised to power, so 2 raised to power 4 raised to power 3 plus 1. So we are checking for 16 cube plus 1. This can give us a remainder as minus 1. So m could take a value of 12. Correspondingly, n has to have a value which is still even here, taking out 4. So it has to have powers which are more than 4. So m could be multiple of 4, that is 4. 8 I'm not counting right now. 12, 16 goes away, 20. Here power of m2 was 0. Here power of 2 is 1. Here power of 2 is 2. 4, 12, 20, 28. So 4 cases. Correspondingly, n will have a power of 2 which is 3 or more. So 8, 16, 24. So for these 4 cases, n can have these 3 cases. So 4 into 3, 12 further cases. Then we look at the case where m has a power of 2 as 3. 3 is 8 and 24. Correspondingly, n could be power of 2 as 4, which is 16. So 2 into 1 case here. So total number of cases will be 225 plus 56 plus 12 plus 2, which will come out to 56 plus 12 is 68, 70. 70 plus 225 is 295. Now, this is an extremely, for me at least, a very extremely difficult question. A real brain teaser in that sense. Definitely not something I'll try to attempt in the examinations. And also, once I figure it out, it will take at least 3.5 minutes to get solved. The least common multiple of a positive integer n and 18 is 180. LCM of n and 18 is 180. 18 is 2 into 3 square. 180 is 9 into 2 into 10, or 9 into 4 into 5. So 2 square into 3 square into 5. That means n has to have the power of 2 as 2 square. The power of 3, because 3 square is already there, the power of 3 could be 3 raised to power 0, 3 raised to power 1, or 3 raised to power 2. In all the cases, we'll get 3 raised to power 2. Plus, we need a 5 as well. So one of these 3 cases will be n. Next, the greatest common divisor of n and 45 is 15. GCD or HCF of n and 45 is 15. N and 45. 45 is 15 into 3. N has to be there for a multiple of 15 and something, which it does not include extra 3s and 5s. So basically, from here I can say that n will have exactly 1 power of 3. And therefore, the value of n that we get is 2 square into 3 into 5, which is 60 becomes the answer. What is the sum of digits of n? 6 plus 0, 6 is the answer that I will key in the answer box. Now, in terms of level of difficulty, I said this is also a moderate to difficult question. Might take some time to strike as to what values we are looking at. 2.5 minutes should be good enough to answer the questions otherwise. So, as I said, overall level of difficulty of the test, I'm calling it a difficult test. And as I said, 5 to 6 questions would be a good attempt. When I say ideal time 20 to 23 minutes is when we do not sit down and get lost with questions like question number 9. We are taking it like a test. So we look at the question, try our best, and move on as quickly as possible. In that case, we'll be able to go through the test number 23 odd minutes. If I had to choose questions, what would be my choice? I would have chosen the first 5 questions and gotten my 5 to 6 questions correct from there. Maybe the 6th question could be the 6th question that I attempt. Which are these questions? Definitely doing this direct HCF application. Doing this as well. Just had to find the Euler number. Doing this as well. This was, I think, one of the easiest questions in the test. This is also standard HCF finding question. This is a standard process. So 1, 2, 3, 4, 5 is something that I would have done. From here, I'm taking a call. If I've done this question earlier, I will try. This is not a question I would have looked at in the examination because getting that equation written and then working from there, reaching that equation was a challenge for me. This question also, because of the options, I was able to work out. In the exam, I would not consider this as my top 5 question for sure. This is not a question I would have picked up in the examination or otherwise. Again, this question, not very difficult, but if I have to choose the 5 or 6, which will give us a good percentile, this may not make the cut. So my attempt would be 1, 2, 3, 4, 5. And if possible, 6. That would be it in this test.